We've seen how to differentiate sine and cosine and tangent, but how do I differentiate secant? So let's differentiate secant, and one way to get a handle on secant is to write secant as a composition of two different functions. If I set f of x equal 1 over x and g of x equals cosine x, then f of g of x is secant x. So if I want to differentiate secant, it'd be good enough to differentiate f of g of x. And I can do that differentiation problem by using the chain rule. Now I can separately calculate the derivative of 1 over, it's negative 1 over x squared, and the derivative of cosine is negative sine. So putting this together, the derivative of secant must be the derivative of f, which is minus 1 over its input squared, at g of x, and g is cosine, so it's negative 1 over cosine squared, that's f prime of g of x, times the derivative of g, which is minus sine. Now I can put this together, the minus signs cancel, and I'm left with sine x over cosine squared x. But people don't usually write it this way. I could instead write this as sine x over cosine x times 1 over cosine x. In other words, I could write this as, well, what's this term? This is tangent and this is secant, so I could write this as tangent x secant x. So the derivative of secant x is tangent x times secant x. We can play the same kind of game to differentiate cosecant. So what about the derivative of cosecant x? Well, think about how I can rewrite cosecant, right? Cosecant is the composition of the 1 over function and sine, right? Cosecant is 1 over sine. So this is the derivative of f of g of x, where f is 1 over and g is sine. And by the chain rule, that's the derivative of f at g times the derivative of g. And now I know what the derivatives of these functions are. The derivative of 1 over is minus 1 over x squared, and the derivative of g is cosine x. And consequently, the derivative of cosecant x must be minus 1 over, that's the derivative of f, at g of x, which is sine, so it's sine squared, times the derivative of g, which is cosine x. And I can combine these to get minus cosine x over sine x times 1 over sine x. In other words, minus cosine over sine, that's minus cotangent x, and minus 1 over sine, well, that's cosecant again. So the derivative of cosecant x is minus cotangent x times cosecant x. Now we can complete the story by differentiating cotangent. Okay, so how do I differentiate cotangent x? Well, we actually have some choices. One way would be to write this as the derivative of cosine x over sine x, because this cotangent is cosine over sine, and then apply the quotient rule. Or I could use the fact that cotangent is 1 over tangent, and then differentiate this using the chain rule. To differentiate 1 over something, that's negative 1 over the thing squared, times the derivative of the inside function, which is tangent x. And I know the derivative of tangent x, that's secant squared. So this is negative 1 over tangent squared x times secant squared x. And that means the derivative of cotangent is negative secant squared x over tangent squared x. But people don't usually write it like this. Instead, I could simplify this. Having a secant squared in the numerator is as good as having a cosine squared in the denominator, and having a tangent in the denominator is as good as having cosines in the numerator and sines in the denominator. So negative secant squared over tangent squared is the same as negative cosine squared over cosine squared times sine squared. Now these cosines cancel, and what I'm left with is negative 1 over sine squared x. But people don't even write it this way, right? 1 over sine, well, that's cosecant. So this is actually negative cosecant squared x. Now that we've seen the derivatives of all 6 of our trig functions, how are we supposed to remember these derivatives? Well, here's a table showing all the derivatives of these 6 trig functions. And you can see there's some real patterns to this table. The derivative of sine is cosine. The derivative of cosine has a negative sign. The derivative of tangent we saw as secant squared, And the derivative of cotangent is cosecant, but with a negative sign. And the derivative of secant we just saw is secant tangent, and the derivative of cosecant is negative cosecant cotangent. So there's definitely some symmetry here, and you can exploit that symmetry to help you to remember these derivatives.